In this video, we're going to be covering numbers and expressions, converting algebraic expressions into verbal expressions, and verbal expressions into algebraic expressions. These are really important when we deal with word problems, really knowing how to read something and how to interpret it into an algebraic problem, something that we can solve using numbers. So let's get started with number one. It's asking us to write each as a variable expression. So we're basically writing down what we are reading algebraically. So one way you can write this is 17 minus 6, or the difference of 17 and 16. Of 17 and 16. Okay, number two. We can write this in a couple different ways. I'm going to do one way on 2, and I can see 4 and 6 are going to be different. It's basically the same thing, and we'll write them in different ways. So number 2, let's say 8 more than 4. Okay, number 3, this we're going to write 3 to the third power, or 3 to the third. You could also write it 3 cubed. Number 4. So I'm going to do it a different way, or write it in a different manner than I did in number 2. So instead of saying 10 more than 9, I'm going to say 9 increased by 10. 9 increased by 10. Okay, number 4. So I can write this as 4 cubed, 4 to the third. Let's just write 4 cubed. Okay, number 6. You can say 12 plus 9, or the sum of 12 and 9. Number 17. Number 7. So let's just do what we would see it as, 11 plus 11. Number 8, we can write this as 7 less than 20, the difference of 20 and 7, 20 minus 7. Let's just put 7 less than 20. Okay, number 9. Let's write this one as the difference of 16 and 7. I'm just going to put DIFF. That's the difference of 16 and 7. Number 10, 2 times 9. So we can just write 2 times 9. Another way to write that is the product of 2 and 9, or twice 9. Number 11, we can write this as 2 squared, 2 to the second power, the second power of 2. I'm just going to write 2 squared. Okay, number 12. This one we can write as the difference of 21 and 8. Okay, so that's converting algebraic expressions into verbal expressions. So now we're going to do the other way and convert verbal expressions into algebraic expressions. So let's start with number 13. So this one says 10 less than 14. So we start with the 14, and it's 10 less than that. So you got to kind of understand how to read it. You wouldn't write it 10 minus 14, because it's not 14 less than 10. We're taking 10 less than what we originally started with, and what we originally start with is actually 14. Even though it's written after the 10, it's what we originally started. So that's why it's 10 less than 14. Number 14, half of 16. So we can write this as you see it, half, 1 over 2, and in math, of means multiply, so we can write of 16. And if we just have the 16, remember it's over 1, so when we multiply those, we end up with 16 over 2, which is another way to write half of 16. Number 15. The quotient of a number and 6. So you have to be careful not to reciprocate this. So for example, let me just tell you what the answer is. Let's say the quotient of a number and 6. So let's say the number is x and 6. So quotient in math is the answer of a division problem. So you have to be careful though not to put 6 over x, because they told us it's the quotient of a number x and 6. So because they said x first, we have to put that in the numerator and that 6 in the denominator. Okay, number 16, v squared. So v being a variable, squared means to the second power. Number 17, t more than 9. So again, like I think it was number 13 where we had an original amount. So number 13 we started with 14. In number 17 our original amount is 9 in this case, because it's saying t more than 9. So 9 is our original number, so we should write 9 first and then t more than that. So 9 plus t. 18, 3 cubed. So we have that 3, and then cubed is to the third power. Okay, number 19. The quotient of 24 and 8. Again, quotient is a division, and the 24 came first, so we're going to put 24 over 8. Number 20. The sum of 2 and 12. The sum means addition, 2 and 12. Because addition is a commutative property, you can actually put 12 plus 2, you'll get the same answer, but it's good practice to make sure that you do do it in the order that you read it. So just do that for good practice. Number 21, p cubed. Again, p is our variable and cubed is to the third power. 22, the product of 5 and x. So you should be writing it as 5x. Another way to write that is 5 times x. You could also write it 5 times x, but the reason that I would say don't do this way is because the x as a multiplication looks almost the same as x the variable. So just to avoid what's what, make sure that you do write things in a manner that's most convenient to read and is not going to get confused with different methods, whether it's it looks like 5xx. Make sure that because then you can rewrite that as 5x squared if that's what you're writing, but make sure that you put things in terms that are easy to read. Okay, number 23, 2 to the 4th power, which is just, sorry, they didn't say to the 4th power, so 2 to the 4th. But when we read stuff like that, 2 to the 4th, it is 2 to the 4th power. So let's go ahead and write it like that. Redo that. Okay, number 24, twice 11. Twice means 2 times 11. Okay, number 25. Evaluate each expression. So now they want you to actually solve these out and get a numerical value if possible. So this one is saying 10 minus 6. So let's write that as we would read it. 10 minus 6 equals 4. Okay, number 26. 2 cubed. 2 to the third power is 8 because 2 times 2 times 2 is 2 to the third power. 2 times 2 is 4, times this 2 gives us 8. Okay, number 27. Twice 12. When we do that, we end up getting 24. Okay, number 28. 11 increased by 5. 11 increased by 5. When we add those up, we end up getting 16. Okay, number 29. 6 times 10. 6 times 10. Multiply those, we end up getting 60. Number 30. 4 times 8. So we're just going to go ahead and write it as we read it. 4 times 8, and when we multiply those, we end up getting 32. And this was numbers and expressions.